this down here for right now. We're going to describe how to calculate the probability of Walter making R free throws out of N free throw attempts. So for example, if he's going to shoot 3 free throws and we want to know the likelihood of him making 2 of them, then the exponent on the 2/3 is 2 for the 2 makes, and the exponent on the 1/3 is 1 for the 1 miss. So therefore, with that example in mind, we could write 3C2 probability of make to the 2 power times probability of miss to the 1st power. And if we have those probabilities of making and missing, then these would just become those fraction, decimal, etc., however you're recording the probability, and then calculate it. To write an expression to calculate the probability of Walter making R free throws out of N free throw attempts, this is our formula. And I want to acknowledge all of this, 1 minus P of A, might also be known as the probability of not making it. If A represents make, then this is the calculation for a miss. But I like the 1 minus piece of A. It looks more complicated, but really it's actually keeping things more simple. Let's see if you can figure out why. Don't get stuck on the letters. Don't get stuck on the expression like, oh my God, there's so much. No, understand the intention behind it, and it will be a much more understandable conversation. Write an expression to calculate the probability of Walter making R free throws out of N free throw attempts. NCR times probability of A to the R power times 1 minus the probability of A, double parentheses there for the open, open, shut, shut. N minus R, close it all. And I'm going to put on my formula card as well parentheses up here because I notice in Desmos or on the TI Inspire or anytime we're doing a calculation, your exponent, if you don't put parentheses around this exponent, that minus R might blend down to this level. And we don't want it to be on that level. We want the minus R to be up in the exponent. Save yourself a calculation mistake. Walter's free throw shooting is not as good as it was in the past. He used to make 2 out of every 5. Not as good in the past. So he's better now. So the probability of a make is 2/5. The probability of a miss is 1 minus 2/5. Or 5/5 minus 2/5, which is 5 minus 2 over 5. That's the one dealt with as a fraction. This is how you subtract fractions. There's your answer. This is 10 choose 8. Okay, so 10 choose 8. I'll do this with the other color. This is 10 factorial over 10 minus 8 factorial times 8 factorial. So 10 times 9 times 8 factorial over 2 factorial times 8 factorial. The 8 factorials cancel. 2 factorial is 2. 10 divided by 2 is 5. The answer for this is 45. Let's go check the calculator. Let's go and get rid of this previous calculation. Thank you for sticking along the way. Menu, 5, 3, 10, choose 8. There it is. Okay, love it when it works the way it's supposed to. So then let's continue on. The probability of making is 2/5 to the 8th power because he's got to make 8 shots. Remember, that's how the formula goes. That exponent goes here. The probability of missing is 3/5. And 10 minus 8 is this exponent. Now we go to the calculator again. In fact, I'm going to type all of it in the calculator just because I can. Okay. So NCR, I can just straight type that. NCR from the keypad. 10 choose 8, comma, there we go, times, we have 2/5 to the 8th power, move over, times 3/5 to the 2nd power, and whoa, that's a crazy, large fraction. Thank you very much, sorry about that. So then if I go Control Enter, I get a decimal of 0.010617. That is not likely at all. 0.010617. And then as a percent, if I multiply by 100, so multiplying by 100 gives me 1.0617%. That is not likely. He was not a good free throw shooter. And this is where we would say, yeah, he probably is not going to make 8 free throws out of 10 shots if his free throw percentage is so bad. But then it improved. You go, Walter. Look at you putting in work. Okay, so now his goal is to make 9 out of every 10 free throws consistently. And if he's able to achieve that, shooting 90%, then what's the probability that he's going to make 8 out of 10 free throws at a random time, like in a game, getting ready to go to the line and earn some points for the team? It's still 10 choose 8, which is 45, but now the probability of a make has changed from 2/5 to 9/10, and missing is 1/10. So the probability is going to be determined as 45 times, now I'm going to go 9/10 to the power of 8 times 1/10 to the power of 2. Whoa, I don't like that fraction. I'm not writing that fraction down. 387,420,4 387,400, no, 1,420,489 out of 2,000,000, 2 billion. Why would we make our fractions so big? Let's just go to a decimal answer. And the decimal answer is 19.37%. I'm going to write down the decimal first, 19371. But if I multiply by 100, that'll turn this into a percentage. So timesing by 100 means 19.371%. What's the probability of Walter making 8 out of 10 free throws? If he's got 90% shooting, there's a 9 out of 10 chance he's going to make it. Then put him on the line. Why isn't that a higher percentage? Why isn't that like 90%? If he's going to make 9 out of 10 free throws, why is he not going to make 8 out of 10 free throws close to the 90%? What's the difference? You see, the thing is, independently of each other, his free throw chance of shooting one shot is 9 out of 10. But as soon as you start layering and stacking in multiple shot attempts, being consistent, that consistency scale goes down. That's why they, evaluate NBA players so strongly. If you're a high free throw shooter and you think, yeah, making 95% of his free throw attempts, well, put him on the line and let's see if he's going to make 3 shots in a row for getting fouled shooting a 3. Or over the course of a game, hitting all shots consistently is so challenging to do because every time a shot is taken and you add it up to all of the other shots taken, the probability of actually making that many shots is going to continually drop because that's the mathematics of multiplying by fractions. The more fractions you multiply together, the smaller your number gets. With that in mind, this is question 8 out of a giant activity number 1. And you've been amazing for watching all of it, going all the way through it. Page 887. Fortunately, in the next video, all 8s, 888, we do something a little different. Not too far off, but we definitely have put like a close to this chapter. So thank you for watching this episode, and I'll see you in the next one. Page 888 is next. Have a good one.